In the perpetual darkness of Earth's final frontier, where sunlight has never touched and pressure would crush the human body in an instant, there exists a realm so alien that it might as well be on another planet entirely. Here, in the deepest reaches of our oceans, dwells a creature whose very existence challenges our understanding of life, love, and the extraordinary lengths to which evolution will go to ensure survival. This is the story of the anglerfish, a being so bizarre, so perfectly adapted to its hellish environment, that nature herself seems to have crafted it from the stuff of nightmares and dreams in equal measure. It is a tale of sexual parasitism so extreme that it defies comprehension, of predatory cunning that would make Machiavelli himself blush, and of evolutionary trade-offs so profound that they rewrite the very rules of what it means to be alive. Welcome to Animal Uncovered. I'm your host, taking you on a journey to the very bottom of the world, where the strange and the beautiful dance together in eternal darkness, and where one of nature's most extraordinary life cycles unfolds in the crushing depths of the abyss. Chapter 1. Into the Abyss. Picture, if you will, descending through layers of ocean that grow progressively darker, colder, and more alien with each passing metre. At 200 metres below the surface, the last traces of sunlight fade into memory. At 1,000 metres, we enter what marine biologists call the bathypelagic zone, the midnight zone, where eternal darkness reigns supreme and the pressure reaches 100 times that of the surface. Here, in this vast underwater desert, water temperatures hover just above freezing. The pressure is so immense, over 1,400 pounds per square inch, that it would instantly collapse a human lung, yet it is in this seemingly impossible environment that the anglerfish has not merely survived, but thrived for millions of years. The deep sea is Earth's largest habitat, covering more than 90% of the living space on our planet, yet it remains more mysterious to us than the surface of Mars. Recent research suggests that anglerfish suborders most likely diverged from one another during the late Cretaceous and Paleocene periods, making them ancient mariners of the deep, witnesses to the rise and fall of entire geological ages. In this realm of perpetual midnight, the rules of existence are rewritten entirely. Food is scarce, so scarce that when a meal presents itself, it cannot be allowed to escape. Energy conservation becomes not just advantageous, but absolutely critical for survival. Every calorie burned must be justified, every movement calculated with the precision of a master chess player contemplating their next move. It is here, in this most inhospitable of environments, that evolution has crafted perhaps its most ingenious and disturbing reproductive strategy, one that transforms the very concept of romantic partnership into something that would be unrecognizable to any surface dweller. Chapter 2. The Living Lure. In the absolute darkness of the deep sea, light becomes currency, the most valuable commodity in an economy of survival, and the anglerfish, with evolutionary cunning that borders on genius, has learned to mint its own. Suspended from the anglerfish's head like a macabre fishing rod is one of nature's most sophisticated hunting tools, the Elysium, topped with its glowing esque, a biological lure that pulses with an otherworldly blue-green light. This is not merely bioluminescence, this is biological warfare conducted at the molecular level. The light emanates not from the anglerfish itself, but from symbiotic bacteria that have formed one of the ocean's most remarkable partnerships. These microscopic allies, acquired from the environment rather than inherited, have undergone such extensive genetic reduction that they can no longer survive independently. They have become living light bulbs, their entire existence devoted to producing the ethereal glow that will spell doom for countless unsuspecting victims. This borrowed bioluminescence represents a creative evolutionary workaround that transforms the anglerfish from a sluggish deep-sea dweller into one of the ocean's most efficient predators. The bacteria within the esker produce light through a chemical reaction involving luciferin and luciferase, the same process that creates Firefly's summer evening dance, but here repurposed for a far more sinister ballet. The anglerfish positions itself in the water column with the patience of a monk in meditation, its massive mouth agape, revealing rows of needle-sharp teeth that curve inward like the bars of a living prison. The lure dances hypnotically in the water, mimicking the movement of small prey, a wounded fish, perhaps, or a succulent copepod drifting helplessly in the current. To the hungry eyes of deep-sea creatures, fish that may not have eaten in weeks or even months, this glowing morsel appears to be salvation itself. They approach with desperate hunger, drawn by instincts honed over millions of years of evolution, never suspecting that they are swimming toward their doom. When prey ventures within striking distance, the anglerfish's response is instantaneous and devastating. Its jaw mechanism can extend forward with explosive speed, creating a suction so powerful that it literally vacuums the victim into its cavernous mouth. The entire process takes mere milliseconds, faster than the human eye can follow, faster than the prey can react. With its bucket-sized mouth bearing razor-sharp teeth and tiny frosted eyes, the anglerfish has evolved into a living bear trap, perfectly calibrated for its harsh environment. Those inward curving teeth ensure that nothing, once caught, can ever escape. The prey is swallowed whole, often still alive, to be dissolved slowly by powerful digestive enzymes in the anglerfish's expandable stomach. This hunting strategy represents one of evolution's most elegant solutions to the problem of energy scarcity in the deep sea. Rather than expending precious calories in pursuit of prey, the anglerfish has become a living mousetrap, allowing its victims to come to it. In an environment where a single missed meal might mean the difference between life and death, such efficiency is not merely advantageous, it is essential for survival. Chapter 3. The Great Divide. But it is in the realm of reproduction that the anglerfish reveals its most astonishing adaptations, beginning with a sexual dimorphism so extreme that early marine biologists believed they were observing entirely different species. The female anglerfish is a formidable creature, an apex predator that can grow to lengths of more than 3 feet and weigh several pounds. She is the embodiment of deep-sea power, equipped with that devastating lure, expandable jaws, and a digestive system capable of processing prey larger than herself. She's perfectly adapted for hunting, for survival, for the endless battle against starvation that defines life in the abyss. The male, by contrast, appears to belong to an entirely different evolutionary strategy. Males are often 10 times smaller than females and have no function other than to reproduce. While the female grows into a fearsome predator, the male remains diminutive, sometimes no larger than a human thumb, with a body plan that seems almost rudimentary by comparison. This extraordinary size difference is not merely unusual, it represents one of the most extreme examples of sexual dimorphism in the animal kingdom. To put this in perspective, imagine if human males averaged 6 inches in height, while females grew to 60 feet. Such is the scale of difference we observe in certain anglerfish species. The male's entire anatomy reflects a life dedicated to a single, overwhelming purpose: finding and fertilizing a female. His eyes, proportionally much larger than the female's, are optimized for detecting the faint bioluminescent signals that might indicate a female's presence in the vast darkness. They possess highly developed scent organs to track down females, allowing them to detect and follow chemical trails across miles of open ocean. Unlike his mate, the male anglerfish lacks the sophisticated hunting apparatus that makes the female such an effective predator. He has no lure, no expandable jaws, no ability to capture large prey. His mouth is small, his teeth weak, his entire body streamlined not for hunting, but for one epic journey across the dark expanse of the deep sea. This sexual dimorphism reflects one of evolution's most fundamental trade-offs. In an environment where resources are scarce and finding a mate is extraordinarily difficult, natural selection has favoured a strategy where one sex, the female, specializes in survival and growth, while the other, the male, specializes entirely in reproduction. The female becomes a living fortress, capable of surviving for years in the harsh deep-sea environment. The male becomes a guided missile, programmed with a single mission: find a female and ensure the continuation of his genetic line. This division of evolutionary labour sets the stage for one of the most bizarre and disturbing mating rituals in the natural world, a process so extreme that it challenges our very understanding of what it means to be an individual organism. Chapter 4. The Ultimate Commitment. In the perpetual darkness of the deep sea, finding a mate is not merely difficult, it is nearly impossible. Imagine trying to locate a single specific person in a space the size of North America in complete darkness, with no roads, no landmarks, and no means of communication beyond chemical signals that disperse randomly in three-dimensional space. This is the challenge that faces every male anglerfish as he reaches sexual maturity. These deep-sea anglerfishes, called ceratioids, reproduce through sexual parasitism, in which the tiny males attach to their much larger female counterparts to mate. But the term sexual parasitism barely begins to capture the profound biological transformation that unfolds when male meets female in the abyss. The male's journey begins with an epic migration through the darkness, following chemical gradients so faint that they exist at the very limits of biological detection. He may travel for days, weeks, or even months, navigating by scent alone through a three-dimensional maze of ocean currents and thermal layers. His body burns through its limited energy reserves, driven by instincts so powerful that they override even the most basic drive for self-preservation. When at last he detects the telltale chemical signature of a female, the male's behavior becomes increasingly frenzied. He follows the scent trail with single-minded determination, his proportionally enormous eyes scanning the darkness for any sign of the massive predator he seeks to join. The irony is profound. He is simultaneously hunting for and being hunted by the same creature, for if he approaches incorrectly, he may well end up as her next meal rather than her mate. In some species, the males bite the females and then release once the mating process is complete. But in others, something far more extraordinary occurs, something that transforms the very meaning of biological partnership. When the male locates a suitable female, he positions himself near her body and bites down with specialized teeth that have evolved specifically for this moment. But this is no ordinary bite. As his teeth penetrate her skin, a cascade of biological processes begins that will forever alter both of their lives. The male's jaw begins to fuse with the female's flesh. His circulatory system merges with hers. His organs begin to atrophy, becoming vestigial remnants of their former selves. Over the course of days or weeks, the male essentially dissolves into the female, becoming nothing more than a living sperm-producing appendage attached to her body. This unusual phenomenon of sexual parasitism involves the permanent attachment of dwarf males to much larger females and fusion of their tissues, leading to the establishment of a shared circulatory system. The male's kidneys shut down. He no longer needs them, as the female's circulatory system now handles waste processing for both organisms. His digestive system atrophies. The female will provide all necessary nutrients through her bloodstream. His brain shrinks to a fraction of its original size, retaining only the neural pathways necessary to produce sperm when hormonally triggered. What emerges from this process is a creature that challenges our fundamental understanding of individuality. Is this still two organisms, or has it become one? The male retains his own genetic identity, yet he has no independent existence. He has willingly sacrificed his autonomy, his mobility, his very selfhood, for the chance to ensure his genetic legacy. From the female's perspective, she's acquired what amounts to a permanent sperm bank, a ready source of genetic material that she can access whenever conditions are favourable for reproduction. She no longer needs to expend energy searching for mates or risk the dangers of courtship in the deep sea. Her parasitic partner is always available, always ready to fulfill his biological function. This extraordinary arrangement represents evolution's solution to one of the most challenging reproductive puzzles in the natural world. In an environment where encounters between potential mates are so rare that they might happen only once in a lifetime, sexual parasitism ensures that when such meetings do occur, they result in permanent reproductive partnerships that can last for years or even decades. Chapter 5. A Living Contradiction. The fusion of male and female anglerfish creates a biological entity that seems to exist in defiance of nature's usual rules. Here is a creature that's simultaneously predator and parasite, individual and collective, autonomous and dependent. The merged organism embodies contradictions that illuminate the profound flexibility of evolutionary processes. Even though they form these tight bonds during mating, reproduction occurs via external fertilization, when environmental conditions signal that the time is right, perhaps when food becomes abundant, or when chemical cues indicate the presence of optimal spawning conditions. the female's body begins producing hormones that trigger reproductive readiness in both partners. The female's ovaries swell with thousands of eggs, each one a potential future anglerfish carrying the genetic legacy of both partners. Meanwhile, the parasitic male, responding to the same hormonal signals coursing through their shared bloodstream, begins producing vast quantities of sperm. Despite his diminished physical form, his reproductive organs remain fully functional, ready to fulfill the purpose for which he has sacrificed everything else. When the moment arrives, the female releases her eggs into the dark water column in a spectacular display of reproductive optimism. Thousands upon thousands of tiny spheres drift away from her body, each one carrying the potential for new life. The parasitic male simultaneously releases clouds of sperm, which seek out and fertilize the eggs in the surrounding water. This external fertilization strategy might seem paradoxical. Why maintain such an intimate physical connection, only to reproduce at a distance? The answer lies in the economics of deep-sea survival. By keeping the male permanently attached, the female ensures that sperm will always be available when conditions are optimal for reproduction. Yet by releasing eggs and sperm into the water column, she maximizes the dispersal of her offspring, giving them the best possible chance of finding suitable habitat in the vast emptiness of the deep sea. The fertilized eggs begin their own epic journey, drifting through layers of ocean that represent entirely different worlds. As they develop, the tiny embryos face challenges that would defeat most life forms. They must survive in water so cold it would freeze the blood of surface-dwelling creatures. They must develop in darkness so complete that the concept of vision becomes almost meaningless. They must grow in an environment where food is scarce and predators are abundant. Yet somehow, through mechanisms that still puzzle marine biologists, a tiny percentage of these embryos survive to become larvae, then juveniles, then adults capable of continuing this extraordinary cycle. Each successful reproduction represents a victory against odds so astronomical that they border on the miraculous. The adult female, her reproductive duty temporarily fulfilled, returns to her patient hunting. Her parasitic mate, having served his biological function, settles back into his diminished existence, alive yet not truly living, individual yet not truly independent. He will remain with her for the rest of their lives, a living testament to evolution's ability to push the boundaries of biological possibility. Some females collect multiple males throughout their lives, creating bizarre biological harems where several parasitic partners attach to different parts of her body. These polyandrous arrangements further increase reproductive success while creating creatures that seem more like something from science fiction than from the natural world. Chapter 6. The Price of Survival. The anglerfish's reproductive strategy represents one of evolution's most extreme examples of biological specialization. But like all evolutionary adaptations, it comes with profound costs that illuminate the fundamental trade-offs inherent in the struggle for survival. Consider the male's sacrifice, complete autonomy traded for reproductive certainty. In most animal species, males retain their independence even after mating, free to seek additional partners, to compete for territory, to live lives of their own choosing. The male anglerfish abandons all of this, becoming what is essentially a living organ attached to his mate's body. His consciousness, if such a thing can be said to exist in fish, becomes subsumed into a larger biological entity over which he has no control. From an evolutionary perspective, this sacrifice makes perfect sense. In the deep sea, the chances of a free-living male finding a second mate are essentially zero. By fusing permanently with the first female he encounters, he guarantees that his genes will be passed on, which is evolution's ultimate measure of success. Yet from the perspective of individual experience, the transformation represents a kind of living death, the cessation of independent existence in service of genetic immortality. The female, too, pays costs for this arrangement, though they are more subtle. Sexual parasitism enables anglerfishes to maximize reproductive success, but it also commits her to supporting additional biological mass that provides no immediate survival benefit. The parasitic male must be fed, his tissues maintained, his metabolic needs met, all of which represent energy that could otherwise be devoted to growth, hunting, or survival. Moreover, the permanent attachment of males makes the female a more conspicuous target for predators. A solitary female anglerfish presents a relatively streamlined profile in the water. A female with multiple parasitic males attached becomes a more ungainly creature, potentially less maneuverable, and more likely to be detected by the few predators capable of threatening an adult anglerfish. These trade-offs extend beyond the individual to shape the entire ecosystem of the deep sea. Key adaptations such as rapid diversification, larger jaws, smaller eyes, and more diverse body shapes facilitated the transition of anglerfishes from benthic to pelagic environments. The evolution of sexual parasitism has allowed anglerfishes to colonize ecological niches that would otherwise be inaccessible, spreading throughout the world's oceans and diversifying into more than 160 different species. Yet this success comes at the cost of biological flexibility. Once committed to the path of sexual parasitism, anglerfish species become locked into this reproductive strategy. They cannot easily evolve back to more conventional mating systems, even if environmental conditions change in ways that might favour such a shift. Evolution has painted them into a corner of biological specialization from which there may be no escape. The implications extend population genetics as well. In most animal species, genetic diversity is maintained through the mixing of genes from multiple partners over multiple generations. But in anglerfishes with permanent sexual parasitism, each female typically reproduces with the same male or small group of males throughout her entire life. This reduces genetic mixing and could potentially make populations more vulnerable to disease or environmental change. Despite these costs, the anglerfish's reproductive strategy has proven remarkably successful over geological timescales. The multiple families of deep-sea anglerfishes, as well as their trademark sexual parasitism, originated during the Eocene in a rapid radiation that filled ecological niches throughout the world's oceans. Their success demonstrates that in extreme environments, extreme adaptations may be not just advantageous, but necessary for survival. The anglerfish thus serves as a living reminder that evolution does not optimize for human concepts of dignity, independence, or individual fulfillment. It optimizes only for the successful transmission of genetic material to the next generation, and it will employ whatever strategies, no matter how bizarre or disturbing, necessary to achieve that goal. Chapter 7. Diversity in the Darkness. The deep sea is not a uniform environment, and the anglerfishes that inhabit it have evolved a spectacular array of variations on their basic theme of sexual parasitism. From the crushing depths of oceanic trenches to the relatively shallow waters of the continental slope, different species have refined this reproductive strategy in ways that reflect the subtle but crucial differences in their environments. In other anglerfishes, the male is closer in size to the female and only encounters her to mate, spending the rest of their lives hunting for themselves and swimming freely in the ocean. These species represent evolutionary experiments in reproductive strategy, some maintaining traditional courtship and mating systems, while others push the boundaries of sexual parasitism to ever greater extremes. Recent research has revealed that the diversity of anglerfish species is far greater than previously imagined, with new species being discovered regularly as deep-sea exploration technology advances. Each species represents a unique solution to the fundamental challenges of deep-sea existence, with variations in body size, lure structure, reproductive strategy, and ecological niche that demonstrate evolution's remarkable creativity. Some species have evolved lures that pulse with different rhythms, creating species-specific signals that help ensure mating occurs between compatible partners. Others have developed multiple lures or lures with complex branching structures that may attract different types of prey. Recent discoveries have even documented biofluorescence in deep-sea anglerfishes, adding yet another layer of complexity to their already sophisticated light-based communication and hunting systems. The geographic distribution of anglerfish species provides insights into the history of ocean basins and the processes that drive speciation in the deep sea. Some species are found throughout the world's oceans, suggesting either recent global dispersal or ancient evolutionary origins that predate the current configuration of ocean basins. Others are restricted to specific regions, indicating more recent evolutionary divergence or adaptation to local environmental conditions. These patterns of diversity and distribution remind us that the deep sea, despite its apparent uniformity, contains a multitude of microenvironments that can drive evolutionary divergence. Temperature gradients, current patterns, food availability, and chemical composition all vary across the ocean basins, creating selective pressures that shape the evolution of local populations and eventually lead to the formation of new species. The study of anglerfish diversity also illuminates broader patterns of evolution in extreme environments. The deep sea shares certain characteristics with other extreme habitats: Antarctica, high-altitude mountains, deep underground caves, where life faces similar challenges of resource scarcity, environmental extremes, and isolation. In each of these environments, evolution has favoured similar strategies: energy conservation, specialised feeding mechanisms, and reproductive adaptations that maximise the chances of successful mating, despite sparse population densities. Chapter 8. Windows into Evolution. The anglerfish's extraordinary adaptations offer profound insights into the fundamental processes that drive evolutionary change. Their sexual parasitism represents an extreme example of how environmental pressures can push life forms towards solutions that seem to violate basic biological principles, yet prove remarkably effective in their specific ecological contexts. The evolution of sexual parasitism in anglerfishes illuminates several key evolutionary concepts. First, it demonstrates how extreme environmental constraints can favour equally extreme adaptations. The deep sea's combination of darkness, sparse food, and low population density creates conditions where conventional reproductive strategies become ineffective, opening evolutionary pathways toward more radical solutions. Second, the anglerfish story illustrates the concept of evolutionary trade-offs with exceptional clarity. Every adaptation carries costs as well as benefits, and evolution proceeds by balancing these trade-offs in ways that maximize overall reproductive success. The male anglerfish's sacrifice of independence for reproductive certainty represents perhaps the most extreme example of such a trade-off in the animal kingdom. Third, anglerfish evolution demonstrates how seemingly impossible biological transitions can occur through gradual steps. The transition from conventional mating to full sexual parasitism likely occurred through intermediate stages, perhaps beginning with males that simply remained near females for extended periods, then evolving temporary attachment mechanisms, and finally developing permanent fusion capabilities. Each step in this progression would have been favoured by natural selection under deep-sea conditions, leading eventually to the extraordinary reproductive strategy we observe today. The molecular mechanisms underlying sexual parasitism are beginning to yield to scientific investigation, revealing the genetic and biochemical processes that make such extreme biological integration possible. The establishment of a shared circulatory system between male and female represents a remarkable feat of biological engineering that requires precise regulation of immune responses, tissue compatibility, and physiological integration. Understanding these mechanisms has implications that extend far beyond marine biology. The ability of male and female anglerfishes to merge their circulatory systems without triggering lethal immune responses could provide insights into tissue compatibility and organ transplantation in humans. The process of controlled tissue fusion might inform research into regenerative medicine and tissue engineering. Moreover, the anglerfish's reproductive strategy serves as a natural experiment in the evolution of cooperation and conflict between the sexes. In most animal species, males and females have partially conflicting evolutionary interests. Each individual seeks to maximize their own reproductive success, which may come at the expense of their partner's success. But in anglerfishes with permanent sexual parasitism, these conflicts are essentially resolved through the complete subordination of male interests to female interests. This resolution of sexual conflict through extreme specialization offers insights into the evolutionary dynamics of cooperation more generally. It suggests that under certain conditions, evolution can favor the complete sacrifice of individual interests in service of collective success, a principle that may apply to other forms of biological cooperation, from the evolution of multicellularity to the organization of social insect colonies. Chapter 9. Challenges in the Abyss. Life in the deep sea presents challenges so severe that they push biological systems to their absolute limits. For anglerfishes, every aspect of their existence reflects adaptations to an environment that seems fundamentally hostile to life as we understand it. The pressure at anglerfish depths, often exceeding 100 times atmospheric pressure, requires specialized adaptations in every organ system. Proteins must be modified to function under these extreme conditions, maintaining their structure and function despite forces that would denature most biological molecules. Gas-filled organs like swim bladders must be modified or eliminated entirely, as they would collapse instantly under such pressure. Temperature presents another formidable challenge. The deep sea maintains temperatures just above freezing year-round, requiring specialized enzymes and metabolic pathways that can function efficiently in extreme cold. Cellular membranes must be modified to remain flexible despite the low temperatures, using specialized lipids that resist freezing. Perhaps most challenging of all is the scarcity of food in the deep sea. Primary productivity, the conversion of inorganic compounds into organic matter, is virtually non-existent in the darkness of the abyss. All energy must ultimately derive from the surface waters, either through the slow rain of dead organic matter that drifts down from above, or through the occasional carcass of a large animal that sinks to the seafloor. This energy scarcity shapes every aspect of anglerfish biology. Their hunting strategy of passive ambush predation minimizes energy expenditure while maximizing the chances of capturing rare prey items. Their slow metabolic rate allows them to survive for months between meals. Their reproductive strategy ensures that when mating opportunities arise, they result in permanent partnerships that eliminate the need for repeated mate searching. The darkness of the deep sea eliminates the possibility of photosynthesis and makes vision nearly useless for most purposes. Yet anglerfishers have turned this challenge into an opportunity, evolving sophisticated bioluminescent systems that function as both hunting tools and communication devices. The symbiotic relationship between anglerfishers and their luminous bacteria represents one of nature's most elegant solutions to the problem of producing light in a lightless world. Chemical challenges abound as well. The deep sea has different oxygen levels than surface waters, requiring specialized respiratory adaptations. The high pressure affects the solubility of gases in body fluids, potentially creating problems with gas bubble formation similar to decompression sickness in human divers. Heavy metals and other chemical compounds may be present in concentrations that would be toxic to surface-dwelling organisms. Despite these formidable challenges, anglerfishers have not merely survived in the deep sea, they have flourished, diversifying into a remarkable array of species that occupy virtually every available ecological niche in the abyss. Their success demonstrates the extraordinary power of evolutionary adaptation to overcome even the most extreme environmental challenges. The study of how anglerfishers cope with deep-sea conditions continues to yield insights that may prove valuable for human technology. Their pressure-resistant proteins could inform the development of materials for deep-sea exploration equipment. Their efficient bioluminescent systems could inspire new approaches to lighting and display technology. Their methods of energy conservation could suggest strategies for designing more efficient machines and systems. Chapter 10: The Eternal Dance. In the perpetual midnight of the deep sea, the anglerfishers continue their ancient dance of survival and reproduction, a ballet that has been performed for millions of years in the crushing darkness of the abyss. Theirs is a story that transcends mere biology, touching on fundamental questions about the nature of existence, sacrifice, and the price of survival in an unforgiving world. Each female anglerfish that glides through the darkness carries with her the accumulated wisdom of countless generations, genetic instructions refined by millions of years of natural selection, behavioral patterns honed by the relentless pressure of survival in the world's most challenging environment. Her glowing lure pulses with ancient rhythms, following patterns that have proved their worth over geological ages. Somewhere in the vast darkness, a male responds to chemical signals so faint they exist at the very threshold of detection. His journey toward her represents both a pilgrimage and a suicide mission, a final act of devotion that will transform him from an independent being into a living component of a larger biological entity. In human terms, his fate seems tragic, even horrifying. In evolutionary terms, it represents the ultimate success, the guarantee that his genetic legacy will survive and flourish. The fusion of male and female creates something unprecedented in the natural world, a creature that challenges our fundamental understanding of individuality and autonomy. The merged organism that results embodies contradictions that illuminate the profound flexibility of life itself. It is simultaneously one creature and two, predator and parasite, ancient and eternally renewable. When the time comes for reproduction, the female releases her eggs into the water column, with an act of faith that spans generations. Each egg represents a potential future, a genetic lottery ticket that might, against overwhelming odds, develop into an adult capable of continuing this extraordinary cycle. The vast majority will perish, consumed by predators or claimed by the hostile environment. But a precious few will survive, carrying forward the genetic instructions that have made anglerfishes among the most successful inhabitants of the deep sea. The larvae that emerge from these surviving eggs begin their own epic journeys through the layered waters of the ocean. They must navigate through different water masses, each with its own temperature, salinity, and chemical composition. They must find food in an environment where sustenance is scarce and competition is fierce. They must avoid predators while growing large enough to become predators themselves. Those that survive to adulthood will eventually face the same choices that have confronted their ancestors for millions of years. The females will develop their lures, establish their territories, and wait with infinite patience for prey to venture within range. The males will embark on their desperate searches for mates, driven by instincts so powerful that they override even the most basic drive for self-preservation. And so the cycle continues, an eternal repetition of themes that speak to the deepest mysteries of existence. In the crushing darkness of the deep sea, life persists not through comfort or ease, but through adaptations so extreme that they seem to mock our conventional understanding of biological possibility. Thank you for joining us on this journey to the bottom of the world, where the impossible becomes possible, and where creatures like the anglerfish continue to illuminate the darkness with their ancient wisdom and their eternal light.